Hi guys, so here I go again. I literally just finished recording, or so I thought I was recording the first meeting, but I was not. So here I am making this video again. Okay, all right. Okay, review one. Which description describes the graphical behavior of the function? Whenever they give you an equation and they don't give you what the graph looks like, you use decimals, okay? So let's type that in decimals. 3 over 4 x minus 5. And you know what? I think I still have it here because look, I did all this work for nothing. Let me see if I could just, you know what? Nah, I'm gonna just write it so I can show you how to type it in. So f parentheses x equals 3 over 4 x minus 5. Okay, so remember, you always read the graph starting from the left side. So if I start from the left side, I start here at the bottom and I follow it. It's going up, that is increasing, okay? So this one is increasing, not decreasing, is not neither, and is not both. Because remember, whenever it's increasing then decreasing, that's something like this. It has some kind of curve, okay? This is a linear function, so it's either just going to be increasing or just decreasing, okay? Whenever I'm going through these notes, I'm not going to write down everything I say. I expect you to write down what you think is important, okay? Or like important things like what I just said about linear functions either increase or decrease, but not both at the same time, okay? Because if I write everything down, it's going to make this video really long, and I really don't want y'all to watch it for that long. Okay. Also, if I'm talking too fast, moving on too fast, just pause it or slow down the video. All right. Anyways, check all the descriptions that describe the graph below. So first of all, you should know that exponential, look at this. In the word, it's a curvy L, okay? The word exponential has an L. Exponential functions are curvy L's, or it could be this way, okay? So we know that it's exponential. Discrete means whenever you have points that are not connected. Do I have points here? No, I don't, right? So it's not discrete. Continuous means when it's some kind of line. It could be a straight line, it could be a curvy line. But the thing is that all these points are connected by the line, okay? Here you can't see it, but this is a point here. This is a point. This is a point. These are all points, but they're connected with the line. So yes, it is continuous. Is it increasing or decreasing? Well, let's go. I'm going to go in from the left side. The first thing I touch is up here. I follow it. It's going down. This is decreasing, right? So write that down. When you read the graph from the left side, if you start at the top, if the first thing you touch is at the top and you follow it with your finger and it's going down, that's decreasing. Not increasing. Not a linear function. We said is exponential, right? Decreasing. So this is another one. So let me put the check mark right there. The graph is not a function. Well, let's see. Remember, for a function, you have to do the vertical line test. And by the way, guys, in the other video that I thought I was recording, I mentioned that I'm using a new program. So I don't see anywhere on here where to erase. So if I make a mistake, unfortunately, I don't know how to erase it. So I'm just going to verbally tell you that it's a mistake, okay? Also, I can't change the colors. And if my handwriting is a little sloppy, it's because I'm doing this on a computer. So I apologize. All right, anyways, moving forward. So I'm going to draw a vertical line. It should only touch one point. And remember, it might be a function on one point, but if you go to another part of the graph, it might not be. So you have to draw multiple vertical lines to double make sure that it's a function. Here, 1 point. Here, 1 point. I could tell you right here, this is a function, okay? So it's not E. And let me put a check mark right here. All right, moving on. Which description describes this? Okay, so again, they gave us an equation and we don't know what the graph looks like. So let's go ahead and graph it. Negative x squared plus 3x. Okay, let me erase this. F of x equals negative x squared plus 3x. Okay, so this is what it looks like. It's a quadratic function. Read it from the left side. It starts down here. So, sorry, it starts down here and it goes up here, so it's increasing. Then look what happens. It starts up here and it's going down, so then it decreases. So it increases and then it decreases. Does it have a max or a min? Well, look at this point right here. Is it at the top of the curve or at the bottom? If the curve is at the top, that's a maximum. Think about maximum, highest point, minimum, lowest point. Okay? So this right here is obviously a maximum. Also, for those of you who are visual people, the word max, let me just draw it out for you. Max, it has a curve, right? And then the curve looks like this is an A, right? But it's a curve like with the upside down U, if y'all can see that. Here you have that curve and you can make an A out of this. I don't know if that helps, but if it does, use it. So this is a maximum. It's not both. It can be both. Well, I can, but not in Algebra 1. You'll see that in pre-cal, okay? It has an absolute minimum, no, and it has neither, no. Okay, so it's that one. So for these, I want you to put graph in decimals. Make a little side note that you have to graph in decimals. All right, moving on. Which one is a function? Again, we're doing the vertical line test. If I misspell things or if my handwriting is a little sloppy, I apologize. But just listen to what I say verbally because I usually say what I write. So just rewind the video and see what I said. Vertical line, so can only touch vertical line test, and that means that it can only touch 1 point. 1 point. So this one is a discrete graph, the first one. That means that the points are not connected. So all of these points right here, you have to draw a vertical line through them. So draw a line here. It only touches 1 point. Sorry if my line is not straight, okay? If I draw a line here, only 1 point here, 1 point here, 1 point. So this is a function. Now this one is a vertical line. So if I draw another vertical line on top of it, guess what? They have all the same points. A vertical line can't be a function. Because if you draw a vertical line and do the vertical line test, then that's just the same line, meaning they have all the same points. So this is not a function, okay? Let me make sure I'm still recording because I don't want to keep talking and then find out that I'm not recording. Okay, I am. Sorry, guys. I just had to make sure because I literally spent like 30 minutes doing this and then it didn't even record. All right, moving on. So if I draw a vertical line here, it touches 1, 2, not a function. Here, same thing. 1, 2, not a function. Any diagonal line is going to be a function. So if I do a vertical line here, it touches 1 point here, 1 point here, 1 point. So this is a function. Okay. This one, also a function. 1 point, 1 point, 1 point, 1 point. You get the point, right? All right. So that one is also a function. All right, moving on. The graph of a quadratic function R is shown on the grid, which best represents the range. So range is y, okay? Sorry, I keep checking to see if I'm recording because I'm paranoid that I'm going to mess it up. Okay. Oh, wait. See, this is what happened last time. It said, are you still there? And I forgot I didn't put anything, so it took me out of it. So I'm going to put stay in the call. So I should be good now. Okay. All right. Anyways, if you struggle remembering what domain and range is, do Dr. XY. Domain goes with X, range goes with Y, okay? And also think about it like this. D comes before R in the alphabet. X comes before Y in the alphabet. So the two letters that come before the other one in the alphabet stay together. The two letters that come after the other two letters on the alphabet stay together. Okay, so range is Y. I could tell you right now it's not going to be B because we're not talking about X, we're talking about Y. Okay, so range, we read it from the bottom. Start from the bottom. What am I touching? I'm touching arrows. Okay, so that means that I'm going to have some kind of inequality. One of these two. Okay, and then I go to the top. Look at the top. I start here. And also another side note, I don't care about the x-axis. So if you want to cross it off, you can. On the test, you probably won't be able to cross it off because it's gonna be on computer. But just cover it with your fingers or something. I don't know. All right, so it starts here, and we care about the y. This is at 8. So I know I have y and I have 8. It's not gonna be all your numbers because it's gonna be something like this. Now, if I start here at the top, okay, I start here at the top and I'm going down. I'm following those arrows because those arrows are pointing down. I follow them. Are the numbers getting bigger or smaller on the y-axis? Hopefully you said that they're getting smaller. So smaller means that it's less than or equal to, which is this one. Okay, if you struggle remembering what less than or equal to means and greater than or equal to, less than looks like this. Okay, it's an L. Less than is an L. The greater than is not an L. It's a backwards L, so that's wrong. Okay, I don't know if that helps, but hopefully it does. All right, moving forward. Now we're gonna find the domain. So domain is X. What? I'll eat in a little bit. I'll try to finish it now. Wait. Thanks. Okay, so domain is X. So we have Dr. XY. Again, domain goes with X, range is Y, right? So we don't care about the Y. We don't care about the Y. Okay, so that's already, if you have to take a lucky guess and you really don't know how to find it, just by knowing that domain is X, you could take a pretty good guess because now your chances of getting it right if you take a lucky guess is 50-50, okay? All right, and also, I'm going to tell you right now, it's not this one. Why? You have two inequalities. When you have two inequalities, that means that it's going to be like this. You're going to have 2 points, okay? Or it's going to be like this, or it could be like this. As long as it's 2 points somewhere, okay? Or it could even be something like this. That's 2 points, okay? Does this have 2 points anywhere? No, you have a point here, even though you can't see the point. This is a point right here because it's here, okay? -2, -5. And you have arrows. So we know that it's not gonna be this one. Okay, that's just a little side note, like a little trick, but let me show you the actual way that you read domain. So you always look at the x-axis, right? You start from the left side, you read it from the left side coming in. What am I touching here? I'm touching the arrow. Now, if I follow this arrow is going this way. What are the numbers doing on the x-axis when they're going this way? They're getting smaller, right? So it's a negative infinity, and they go on forever, so negative infinity. Now for this one, I go from the right side. What do I touch? Arrow again. Now, if I follow this arrow, it's going this way, and the numbers are getting bigger. So this is positive infinity. Whenever we have negative infinity to positive infinity, we call that all real numbers, okay? All right, moving on. Now they're asking, what is the range? Range is Y. Now, this one can be a little bit confusing, but let me see if I can help with that. So range is Y. We don't care about the x-axis, so let's ignore that. And I care about the Y, right? I care about all these numbers going up and down. I always start from the bottom. If I start from the bottom, this is what's happening, okay? Now, I don't touch the arrow. I'm never going to touch the arrow. This one, that's why I say this was confusing because normally I would say touch the arrow, but no. For domain, you would, but not for range. The range here is approaching 0. 0 is right here, right? You see how this line is getting really, 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 really close to 0? That's because it's approaching 0. And if I were to extend this graph, you have 0 right here, then you have -1, -2, -3, -4, -5, right? Is this graph ever gonna reach down here to the negative numbers? No, it's never going to. And if I were to graph this, you would see it too on Desmos. This graph is never going to go towards the negative numbers. So it can't be all real numbers. It can't be -3 to 5. Okay, so remember the bottom is approaching 0. So I have y and 0. Now I look at the top. Top, I do have arrow. The arrow is going down. So if I start here at 0 and I follow this arrow, the number's getting bigger or smaller. They're getting bigger, right? So it has to be greater than or just greater than. The reason why it's not greater than or equal to is not the equal to, sorry. Oh, I shouldn't have written that because now I can't delete it. The reason why it's just like greater than and not greater than or equal to, because remember how I said this is really close to 0, but it's never going to touch 0. So 0 can't be included on that because it's never going to touch it. It's never going to touch it. So it says all real numbers greater than 0, all real numbers less than 0. Like I said, y is greater than 0, so all real numbers have to be greater than 0 because the numbers are getting bigger. Okay, moving on. Identify which tables are functions. So x cannot repeat. Okay, x cannot repeat. Input is your x. This is your x. This is your y, x, y, x, y. I'm gonna cross off all the y's because we don't care about them. Are any of these repeating? No, that's a function. Are these repeating? Yes, that's not a function because remember, they can't repeat. Are any of these repeating up here? Let me cross these off so y'all don't get confused. We don't care about the y. Only these up here. Are they repeating? No, so this is a function. We don't care about these. Are these repeating? No, that's a function. Cross these off, we don't care. Are these repeating? Let me tell you something. -5 and 5 is not the same number, okay? -3 and 3 is not the same number. -1 and 1 is not the same number. Why? Because of that negative sign. So this is a function. -2 and -2, that's the same number, right? Is repeating, so this is not a function. Moving on. Okay, so describe the domain and the range. Domain is x, range is y. So if I go from the bottom, let's find the domain first. I go from the bottom. Remember, I'm focusing on these numbers on the x-axis. I go from the bottom, and what am I touching on the x-axis? 0, right? 0. Now I go from the right. So I know it's x and it's 0. I go from the right, look what I touch, arrow. So that means that if I started at 0 and I follow, so I started here at 0 and I'm following the arrow is going this way to the right, right? Are the numbers getting bigger or smaller? They're getting bigger, hopefully. That's what you said, right? Bigger than, greater than or equal to. So it's not, hold on, oh my goodness, this thing. Let me scroll down. So it's not all real numbers because it has to be something with 0, okay? All real numbers greater than or equal to 0. Okay, that looks good. Now let's find the range. So that was domain. I'm going to put D for domain, now range. Range, you read from the bottom. The bottom is down here. And now we care about the y now. We don't care about the x anymore. The bottom, this is between 200 and 300, so that's 250. So y, 250. Now the top. The top, guess what I touch again? Arrow. So if I start here and I follow my arrow is going up here, the numbers are getting bigger. So again, it's greater than or equal to 250. Okay. Domain, they said all real numbers greater than or equal to 0. That's good. All real numbers greater than or equal to 0 for range? No, because I said 250, right? So this is not it. All real numbers greater than 0. All real numbers greater than 250. Why is this one not right? because it doesn't have the equal to. And the equal to is important here because the 250 is included and the 0 is also included. So it's not that one. Are our numbers greater than or equal to 0? Yes, this is my answer here. Okay. All right, moving on. Which ones are functions? So for this one, again, x cannot repeat. So this is my x, y, x, y, x, y. These cannot repeat. We don't care about the y's. Are any of these that I circled repeating? No, this is good. This is a function. Are these repeating? Let's see. Negative 6 and negative 6 is not the same number. So yes, this is a function because they're not repeating. 3, negative 2, 3. I have 2 3s. That's repeating, so this is not a function. Remember, input is x, output is y. For this one, the x cannot have more than one arrow. If you see that there's a number going to, and it has 2 arrows, then that's not a function because that means that is repeating. So the 0 has 1, 2 arrows. Remember, I don't care about these, right? I don't care about these. I don't care about any of this. I only care about these. This has 1, 2. This is not a function. This one has 1. The 3 has 1 arrow. The 5 has 1 arrow. So this is a function. The 3 has 1 arrow. 1 has 1 arrow, but the 0 has 2 arrows. This is not a function. All right, so that was it for the first review. Let's go ahead and start with the second one. All right, so which statement describes the pattern below? Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm not going to count all these. We can also multiply. Okay, so 1, 2, 3. So 3. 1, 2, 3, 4, 5. 3 times 5 is 15. This is 15 right here. This is 10. This is 5. I'm not about to count all these, okay? 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 times 4 is 20, okay? So we have 5 squares, then we have 10 squares, and 15 squares, and 20 squares. So this is increasing by how much? And the numbers are getting bigger, right? So we know that it's not 5 fewer squares, no, because it's 5 more squares. So it's not 10 fewer squares because it's increasing by 5, not by 10. It's not 10 again because, like how I just said, it's increasing by 5, not 10. And 5 more squares, yes, this is the correct answer. So this was pretty easy. All right, which explicit formula is represented by the graph? So the explicit formula for arithmetic, explicit, I think we went over this last time I saw you guys. You're going to have an, a1 plus d parentheses n minus 1. Your a1 is going to be your first term. D represents the common difference. Common difference is the number you keep adding every time. So here, my first term is 10. My second term is 15. My third term is 20. Fourth term is 25. Fifth term is 30. Sixth term is 35. So this is increasing by 5, right? So that's my common difference right there. Now, what is my first term? My first term is 10. So I'm going to have 10 right here at the front. That's a positive 10. So right here they have negative 5. That's wrong. I want 10. They have 5. No, that's wrong. They have negative 10. That's wrong. The only one that's right is this one. Okay. You know, so plus D, like I said, that's your common difference. The number we kept adding every time was 5. So 5 parentheses n minus 1. That matches B. Okay. All right, moving on. Determine the sequence 0.1 to 800 is arithmetic or geometric. Arithmetic means adding. Okay, adding. Geometric is when you multiply. Think about it like this. Arithmetic starts with an A. Adding starts with an A. There's only 2 things you can do. You can either add or multiply. Okay? So how do I go from 0.1 to 2? Do I add something? Do I multiply something? I don't know off the top of my head, right? So I'm going to work backwards. Let's try adding first. The opposite of adding is subtracting. So I'm going to do 2 minus 0.1. Okay, let's go to decimals real quick. 2 minus 0.1. 1.9. So that means that I want to get that 1.9 again. Okay, now I'm going to do 40 minus 2. I should get 1.9. If not, then it's not adding, it's multiplying. 40 minus 2, I could tell you right now, 40 minus 2 is 38. These are not the same. They're not the same, so it's not arithmetic. Erase that. It has to be for sure geometric. So let's find the pattern. Let's do the opposite of multiplying, which is dividing. So 2 divided by 0.1. I'm going to do 2 divided by 0.1. We're going to go to decimals. 2 divided by 0.1, I get 20. The next one, now I should get 20 again, right? The next one, I'm going to do 40 divided by 2. So let's see. 40 divided by 2, I get 20 again. That's what I want, right? That's my pattern right there. That means that every single time I'm multiplying 20. Now they try to trick you here because they put the 20 right here. So you're like, oh, okay, that's my pattern. So that must be the answer. That's incorrect because the question asks, then identify the next term. So the last term was 800. Now that we know that we multiply 20 to get the next term, we're going to do that to get the next term, okay? So 800 times 20 is 1600, which is C. Okay, so be careful about that one. All right, moving on. What is the 13th term? Whoops. What is going on? How do I get rid of this thing? Okay, here we go. What is the 13th term? So everywhere I see an N, I'm going to plug in 13. So instead of N, I'm going to put a 13 equals 1 plus 1 over 3. Parentheses instead of N, like I said, 13. 13 minus 1. Honestly, you put this right here in the calculator, you get your answer. So let's go ahead and do that. We're going to do, hold on, let me make sure I'm recording. Okay, yeah, I'm still recording. We're good. We're good. So what was it? It was 1 plus 1 over 3, parentheses, 13 minus 1. Wait, I messed up. I messed up because I put the parentheses wrong. Here we go. There we go. That's important. Learn from my mistakes. So you get 5. So now, what's your answer? 5, right? That's it. Pretty easy. Just put it in the calculator. All right, moving on. We're almost done, guys. Determine if the sequence is arithmetic or geometric. Then identify the next term. So this was like the other one. So let's go ahead and try arithmetic first. So I'm going to do negative 232 minus negative 215. So negative 232 minus negative 215. Okay, because remember, if I'm doing arithmetic, that's adding. The opposite of adding is subtracting. So I'm working backwards. Negative 232 minus... Okay, so negative 232 minus negative 215. Negative 17. I want to get that negative 17 again. If I do, then I don't have to do geometric because I know my answer is arithmetic. So negative 249 minus negative 232. I should get negative 17 again, right? Where is it? Negative 249 minus negative 232. Negative 17. That's exactly what I wanted. So good for me. I don't have to do no more work. I know that my answer is arithmetic. So I could delete the geometric. Okay. Now this is similar to the other one. Don't think, oh, it's negative 17, so I'm going to pick this answer. Nope, that's not what they're asking. It says identify the next term. So it ends here at negative 266. But now that I know that I'm adding a negative 17, you're going to put that in the calculator, and that's going to give you negative 283. Okay, so that's my answer. All right, Kimberly is a scientist. She is recording the number of cells in the dish. After each hour, the cell divides into 6 cells. Okay? So this is good because they tell us that is only geometric. That's the only option. Ooh, let me zoom in a little bit because I don't think you can see that. Okay? So the explicit formula for geometric is Gn equals G1 times R n minus 1 to the power of n minus 1. Okay, G1 is your first term. And similar to arithmetic, remember for arithmetic, we had common difference. Here we have common ratio. And that's the number that you multiply every time. So how did they go from 1 to 6? They multiply 1 times 6. 6 times 6 is 36. 36 times 6 is 216. So let's plug in what we know. G1, that's my first term. What's my first term? 1. So I'm going to have 1 times. Actually, I just noticed this is wrong because none of them have 1. But so none of these are right. I apologize for that. I just realized that none of them are right. Okay, so I'll make sure that whenever you're doing this, just don't do this one, and I'll make sure to correct it or take it off so that you don't get points off. R, but let's still do it. R is the common ratio. Common ratio is the number we kept multiplying every time, right? We said to go from 1 to 6, we multiply 6. So right here is 6 and minus 1. This is the correct answer. All right. Moving on. Eloisa's bakery sold 30 dogs the first week. So 30. Second week, 39. Then 48. Okay. This pattern continues. What can be used to find the nth term? So again, is an equals a1 plus d parentheses n minus 1. A1 is your first term. D is your common difference. Okay, my first term is 30, so I should have 30 here. 30, 30, no, I don't have it. Here, they're multiplying. Nope, I want addition. So it's not B and it's not D. So if you have to take a lucky guess from here, your chances of getting it right is 50-50, right? But I should have D is 9 because 30 plus 9 is 39. 39 plus 9 is 48. So I should have a 9 outside of the parentheses. Good. The reason why this one's also not right is because my formula says n minus 1. Not n plus 9 is n minus 1 always. That's always going to be like that. So it's C. All right, moving on. Which is another representation of the explicit formula. So I have 22 plus, so I have to find the first term. So everywhere I see an n, I'm going to plug in 1. A1 equals 22 plus 8 parentheses 1 minus 1. Remember, I'm not putting n anymore. I'm putting 1. Let's calculate this. 22 plus 8. 1 minus 1 is 0. So I have A1 equals 22 plus 8 times 0 is 0. And then 22 plus 0 is 22. So I should have 22 for the first one. I don't have it here. That's wrong. I have it here and I have it here. Do I have it here? The first term 10 is between 10 and 20. Whatever that number is not 22, so it's not D either. So that means I had to find the second term to find my answer. So now I'm going to do A2. 22 plus 8, 2 minus 1. A2 equals 22 plus 8. 2 minus 1 is 1. And honestly, guys, you could just, after you do this, put this in the calculator. I'm just doing all these extra steps to show you the work, but just put it in the calculator. A2 equals 22 plus 8 times 1 is 8. A2 equals 22 plus 8 is 30. So I should have 30. This is wrong. I don't have 30. This one I do. So this is my answer. All right. Next one. Same thing here. We're going to plug in the term. So starting with the first term, G1 equals 15 times 2, 1 minus 1. G1 equals 15 times 2. 1 minus 1 is 0. If you put this in the calculator, the whole thing, sorry. 2 to the power of 0 is just 1 times 15. 15 times 1 is just 15. So 15, 15, 15, 15. Well, that sucks. Now I had to find G2, right? So let's go ahead and do it. 15 times 2, 2 minus 1. And then G2 equals 15 times 2. 2 minus 1 is 1. And I have G2 equals 15 times 2 is just 30. Do I have 30 here? No. Here? No. Here? Yes. Here? No. So my answer is this one. Okay. Last one. Okay, so they give you the sequence A3 equals 0. Remember, this little number right here represents the term number. So this is not term 1. This is term 3. Term 3, term 4, term 5, term 6, term 7. Based on the information, which equation can be used to find the nth term? So you have an equals a1 plus d parentheses n minus 1. Okay, these numbers are all increasing by 8. 0 plus 8 gives you 8 plus 8 plus 8. So I have an equals 8 for d because that's my common difference. Bring everything else down. A1 was my first term. Well, I know it's not 0, even though that's the first number they gave me. It's not 0 because that's the third term. That's what this 3 means. So they try to trick you. So everywhere you see a 0, cross it off because that's not it. And you don't even have to find it because now these two are the same. So you know that this is negative 16. And which one's the only one that matches? B, because right here they put n plus 1 and it should be n minus 1. All right, guys, I really apologize for that was it. Yeah, I think that was the last one. I apologize for turning in this video so late. Hopefully you have time to look over it. If not, then it's okay. You should have still tried to do the review on your own. But I was having technical difficulties, and then I recorded it and realized I wasn't recording. So, yeah, that's my life. But all right, guys, y'all have a great night. I hope you guys do good on the test tomorrow. And hopefully you took some good notes because remember, that's going to be 10 points extra credit. And the reviews are going to be a daily grade. So, y'all have a good night.